All right, here's one. Now look, you see that the inequalities are getting bigger. And so for those of you that are like, man, I love solving these inequalities, it just gives you more extra stuff to do. For those of you that hate inequalities, it gives you a chance to start liking them. Not that we really expect that to happen, but it gives you something to do. Why don't you guys take a minute and try this one out, okay? I can almost guarantee that I'm going to do the one on the right a little bit different than you did, okay? And if that is the case, that's fine. If you did it the same way that I do, that's going to be fine too. And I'll show you why here in a second. But I want to do the one on the left first. So let's solve this one on the left for x. And yeah, I'm still going to keep on this one. The x is on the left and then the numbers on the right. And then, well, that would mean, and again, I'm going to do 2 steps, 2 principles of equality in 1 step here by subtracting 5 from both sides first. So that will zero out the 5. And then the negative 7 minus 5 would be negative 12. But also subtract 6 x's from both sides too, okay? So that's going to give me 6 x's there, which is now greater than negative 12. Dividing both sides by 6. And be careful again, I just want to emphasize this. Some students in the past, even on an exam, they would see something like this. There's the negative, I got to flip the inequality. No, the coefficient is positive. It's not going to affect the inequality, okay? So negative 12 divided by 6 is negative 2. So there's our first inequality. X is greater than negative 2. Or, we got this other one. So let's do this, again, 2 principles of equality in 1 step here. And this one, though, I'm going to put the x's on the right and then the numbers on the left. And that's where the difference may happen between what I'm doing and what you may have done, okay? Why am I doing that, by the way? It's because I have more x's on the right than on the left. It's going to keep the coefficient positive, which means I won't have to worry about flipping the inequality in the end. Some of you may notice that when you're solving these problems. Some of you may not. It doesn't matter. You will end up with the same inequality either way, and I'll show it both ways. If you kept the x's on the left, you'll get the same answer. It's just shown a little bit different, okay? So that means that 5x has to be zeroed out first. Not really first, but at some point here. So that's going to zero that out. 14x's minus 5x's, boom, 9x's. And then that positive 7 has to be zeroed out. So minus 7 there, minus 7. Hey, that's nice. Negative 20 minus 7 is negative 27. And this is all greater than 9x. See, so I now have a positive coefficient. I know now when I divide, I'm not going to have to flip that inequality. And again, whether you do or not, you should end up with the same answer. So divide both sides by the coefficient to make the coefficient of x a phantom 1. Negative 27 divided by 9 is negative 3, which is now greater than x, okay? Now, if you had placed the x's on the left, once again, it's the same inequality. It's just shown a little different. It would have shown as x. Now, still needs to eat the negative 3, right? So that'd be is less than negative. X is less than negative 3. This is the same thing. And between these, again, before I forget, I'm going to put the or statement between those two, okay? Then we'll see if the graph requires any further consideration here, okay? So let's see, where are these numbers? I'll put 0 here on the right. Negative 2 would be first. And then negative 3, something like this. Again, I'm not caring about the spacing because I just want to know that they're in the correct vicinity of each other. That seems like a word to use right now, but whatever. X is greater than negative 2, okay. That's an open circle at negative 2. I'm looking at the red one. And it's eating the x, so this one goes to the right. Okay. Now, my purple one, I'm going to look at this one. Some of you, again, you're looking at the inequalities as arrows. If you do that, you have to keep the x's on the left. That's the only way that will work. But the way that I have done it, I've purposely put the x on the right. Not just to show you that you have to consider that, because you could always change it like this, but because it still works. So, negative 3, yeah, it's an open circle because it doesn't equal the x, but this one does not eat the x, so the line goes to the left. Okay, so there's my graph. And now I'm ready for the interval. So as far to the left as this purple line goes, that's negative infinity. It stops at negative 3, which is not included. So I have open parentheses there, closed parentheses, that's better. Then we got the U for the union or the or statement, starting at negative 2, which is not included, so we got a parentheses there. This one will go all the way to infinity, very long ways away, but it's there, okay? And now I have the inequality, either this one or this one, by the way, and the interval and the graph. Not really in that order, but it still works. Oh, it didn't ask for the interval. I guess I didn't really need the interval, but I still feel good about it.